Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at understanding and applying trigonometric identities. So a trigonometric identity is just an equation involving trigonometric functions that we can use. That's basically all they are. So let's go through the first identity. So we're going to use this right-angled triangle here. So I want to first introduce you to this terminology if you're not used to it, sine squared theta. That just means the same as sine theta all squared. So the reason that it's written like this, sine squared theta, is if you have something like sine 4 squared, it can be ambiguous. Do you mean sine of 16 or do you mean sine of 4? And then square it. So that's why we use this terminology. So here, in this triangle, we're just going to use SOHCAHTOA to find sine theta. So sine theta is equal to opposite over hypotenuse. Easy as. So if I now find sine squared theta, it's just 12 over 13 squared. So square 12 and you square 13. Easy as. So cos theta is going to be the adjacent over the hypotenuse. So cos squared theta is just 5 over 13 times 5 over 13, 25 over 169, right? Nothing groundbreaking yet. But it turns out if I add these two together, I always get 1. So sine squared theta plus cos squared theta is just going to be sine squared theta, which is 144 over 169, plus 25 over 169. So, of course, that equals 169 over 169, which gives you 1. So that is our first identity. It doesn't matter which value you substitute for theta, even if it's not between 0 and 90. Sine squared theta plus cos squared theta always equals 1. That is our first identity. So you're going to look at, in the exercises, proving this for any generic triangle, because it would work for any right-angled triangle I drew there. So that's why sine squared theta plus cos squared theta equals 1. It's actually reliant on Pythagoras, because this squared plus this squared divided by this squared must equal 1. So we can apply this to find, say, a value of cos theta if we know the value of sine theta. So let's say sine theta is 1/4 and we want to find the value of cos theta. Well, we've got this equation linking sine theta and cos theta. So we know that sine squared theta, so this is sine theta squared, plus cos squared theta is equal to 1. So 1/4 squared is 1 over 16. I can just subtract 1 over 16 from both sides. So I get cos squared theta is 1 minus 1 over 16. And then cos theta is just going to be the square root of 15 over 16. And so if I put that on my calculator, the square root of 15 over 16 is about 0.968. That's to 3 decimal places. All right, so that was one identity that we went through. So please pause and copy this down because I'm going to rub out all the working out and we'll go through another identity. Okay, so we'll again turn our attention to this right-angled triangle here. So this angle here is 90, obviously, right? Now, because the angles in any triangle add to 180, this angle plus this angle must equal 90. So if this angle was 30, this would be 90 minus 30. If this angle was 70, this would be 90 minus 70. If this angle is theta, this angle here is 90 minus theta. So we found out before that sine of theta is equal to 12 over 13. We found that cos of theta was equal to 5 over 13. Now sine of 90 minus theta is now going to be the sine of this angle here. So this now becomes the opposite and this is the hypotenuse. So that's actually equal to 5 over 13. So similarly, if I want to take the cos of that angle, if I want to take the cos of 90 minus theta, cos of this angle, now this is the adjacent and this is the hypotenuse. So it would be 12 over 13. So note, these two are equal and these two are equal. This gives us our second identity. Well, it's actually kind of two. So sine of 90 minus theta is equal to cos theta. And similarly, cos of 90 minus theta is equal to sine theta. So these are more identities. So once again, you'll look at showing that for a generic right-angled triangle in the exercises. But it turns out that this works for any value of theta, not just those between 0 and 90. So what this means is sine of 60 is equal to, say, cos of 30. Cos of 20 is equal to sine of 70. Cos of 10 is equal to sine of 80. Cos of 0, which is 1, is equal to sine of 90, which is also 1. So this is another identity that we can go through. Now, it turns out there's sort of one for tan. So if I calculate tan of theta, so tan of this angle here, it's just opposite over adjacent. So it's just equal to 12 over 5. But if I take tan of 90 minus theta, now I'm taking tan of this angle, opposite over adjacent is 5 over 12. You can see that we've just flipped the fraction. So it turns out that tan of 90 minus theta is 1 over tan theta. So we've seen this before in exact values. So we know tan of, say, 60 is root 3. Tan of 90 minus 60, tan of 30 is 1 over root 3. So again, you will just look at proving these for arbitrary triangles in the exercises. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.